Let us have a look here at Lightwave's buffer system. It has an all-new buffer system, and it works with the main renderer and also with VPR. As such, you can preview or rather render buffers here directly in the viewport available from this drop-down. There are two main types of buffer available, and you can see them here as divided. The top set here are information buffers, which give you information about the scene or the render or the objects as an image, whilst the lower set are actual image element buffers. So for instance, we have something like a depth buffer, right, that shows us the depth of elements that are in our scene. Or we have, for instance, a normals buffer that shows us the normals of all of the rendered geometry in our scene. We could perhaps get information like world position that shows us the actual position in world coordinates of each pixel. Object position, of course, that gives us the same information but in the relative object space of each object that's being rendered. We can have camera tangent space that tells us the tangential direction of a given pixel, or rather its geometry at that pixel with respect to the camera plane, and so on and so forth. Then, of course, in the image element buffers, we have all of the components that actually comprise the image itself. So, for instance, we can view the direct specular. This is specularity, of course, coming from direct sources, which are, of course, actually lights. The indirect specular, which is the reflection of objects or whatever in the scene that aren't lights, or, of course, that are being illuminated by global illumination. We can look at the luminous elements, the diffuse elements, again in direct and indirect, and what you'll see is that this list changes depending upon exactly what you have present in the scene. You'll see, for instance, in this particular case that we're showing here, I've got subsurface scattering, direct and indirect. There is no surfacing in here that uses subsurface scattering, but if we have a look in our surface editor, then you'll see that many of my surfaces here are using the principled shader, which of course has a subsurface parameter. As such, the reason that you'll find this list changes or contains things that don't seem to make any sense for a given scene, like in this case subsurface, which is just coming out black because there is no subsurface, is because it depends what shaders you have. If I take one of these surfaces here and let's change it over to, let's say, skin, shall we, for the sake of it, then you can see that I've now got options for the hypodermis, the epidermis, the dermis, as well as, of course, the sheen options here. Now, having these buffers available to us here in VPR is great because, first of all, it allows us to see our buffers and to start rendering straight away with the buffers workflow in mind. But also, of course, it helps us when we are setting up renders and setting up surfaces, because we can come in and have a look at some of these, particular elements of our surfaces or of our render, such as the specular or the diffuse or whatnot. And that can help us to fine-tune our surfaces or our render settings or whatever else, since we can view these elements in isolation. When it comes to doing final renders, then you'll see over here we actually have the buffers tab in the render properties. And you'll see that if you want to have a certain buffer spat out for use by you in the final render, then you need to check it off here as being rendered. And so you can just check these guys in and out. And of course you can multi-select like this and, check render buffer to turn them all on. You can give the buffers custom names if you so choose. Pick a given buffer and just, give it a name like that. You can see that appears in the custom name field. Generally, you would only use these custom names if you are going in a studio workflow where perhaps you're doing renders more commonly, I would think, from different applications, where of course the compositors want to know exactly what buffer is what, and it helps them to be able to recognize them by a specific name. Otherwise, it's probably just best to stick to the default names. You can, of course, set up presets, so you can select a range of buffers that are going to be rendered and indeed any custom names for them, and you can save that as a buffer preset, and of course you can load those presets and so on. Now in this case, these are the buffers that will be rendered, and of course when you do an F9 render, then once we're complete and that pops up in our image viewer, you can see that of course we have the buffer drop down here, and that allows us to view the buffers which we have indeed there rendered. And of course we can save those off individually, or of course we can save all buffers from the option here. When we're doing an F10, so when we're, rendering out a series of frames, rendering an animation, then of course notice over here on the output we choose which rendered buffers here will be saved. And you'll notice of course that the only buffers that are appearing in this list to have the option to be saved are those buffers which I had checked here as being rendered. So if I add some more and we go to output, then we start to see that those ones have been added to the save option. Do of course also notice that you do have to check them off to actually be saved. Of course you select any buffer here and you can set the output type for it. You'll notice that this string flag for buffer name there, that will automatically save each image with the buffer name included. Of course you can set the file format and if you desire a specific colour space for each buffer. This of course is important because if we think about how we're going to use these buffers, then we might recall that when we saw the colour space video we already talked about this, of course, the way that buffers to produce the final render from all of the buffers requires them to be added together, and that needs to happen in linear space. As such, when you're saving the individual buffers themselves, all of the component buffers, you really want to have them saved in linear. Or of course, as we saw in color space, you want the default buffer to be set here to linear. So it's that way when the color space setting is just saving out default buffer color space, it will of course save them as linear. As for how we use them, of course we use them in a compositing workflow. By saving the image component buffers, then of course, that allows you to play around with those in post, so you can color adjust or blur or whatever you want to do to these different elements of the image to get some little tweaks and adjustments in there in post. So you want to strengthen the reflections or weaken the reflections or put a color cast into the diffuse or something, then that's of course a lot quicker and easier to do in post in compositing than it is to go back and re-render your scene. As for all of these information buffers, things like depth, well, in a compositing application you might use that of course to do depth of field blur in post. Things like the motion buffer, which here is currently rendering black because I've got nothing moving in my scene, that would be used of course if you've got a 2D vector blur effect using something like RSMB, Real Smart Motion Blur, or of course there's the blur function in Fusion, also one in Nuke. Other things like Object ID, that allows you to of course create maps that separate out each object, or Surface ID that lets you separate out each individual surface and create a map for those so that you can apply tweaks on an object by object, surface by surface basis. And these slightly more exotic ones like the camera space, tangent space, the normals and so on, those are usually used for relighting effects in post. It would be lovely to go through a nice exploration of all of that stuff here. But of course, the subject of compositing and all of the tricks that you can do there is a whole nother topic unto itself. And so exactly how you would go about using these more exotic buffers will of course depend upon your compositing workflow and indeed the functions for using them that your given compositor has available. Another very useful and important thing that we're able to do with the buffers system is to create our own custom buffers. Over here in the buffers tab, if we go to the edit menu, you'll see that we have this option for create custom buffer. Now you might, for instance, have noticed that in all of this list there was no occlusion buffer, right? And it might be something that you want to render out in order to use. So let's imagine that we were going to do that. We could have a thing here, so let's call it occlusion. And you'll see that down at the bottom we now get this custom buffer occlusion. Of course, if we switch to it, then we'll find that it's all black. It's not automatic just because we've created a buffer and named it occlusion. Lightwave doesn't just know as if by magic that what we're trying to create is an occlusion buffer. However, if we open our surface editor and look at the surfaces of, objects and materials that we have in our scene, then what we'll find is that on the surface destination node, we've had this additional custom buffer added, and this would be the same for as many custom buffers as we chose to add. So if I now get myself the good old occlusion node here, and I plug that fella in, then of course we see that because that's not part of my material, my main render itself, or my main surface, is unchanged. But if I pop on over here to the occlusion buffer, then there is my occlusion material. We can also take note of what Lightwave does or does not render in terms of its render time. So if I just set up a quick camera view here, okay, and I'm just going to hit F9 here to render this. Then there we go, there's our render done, okay, and that has taken 4.7 seconds, right? But of course you'll notice that there is no occlusion buffer being rendered. But of course, if I turn the occlusion buffer on to render, and let's hit F9 again, then there we go, we can see that that's now taken 6.2 seconds. And of course now when I look at my buffers, there is my occlusion buffer. So of course the occlusion in this case has taken additional time to render, but you'll notice that if I don't want it rendered, Lightwave doesn't spend the time rendering the occlusion that I'd set up in the surface like that wastefully when it's not actually required or optioned to be evaluated. That means, of course, that if you're wanting to create specific custom buffers as part of a, pipeline or general workflow, so, perhaps I just want, like, I don't know, perhaps it's the base color of this texture, right? So I can just get that there as a raw color. Or perhaps I want something a bit crazy, like, who knows, the barycentric coordinates of the surface, right? I can just plug that in, and that will, of course, being a vector, render as though RGB. I can set up as many custom buffers as I want. I can have them all connected here in my surface editor, but of course when I do my renders, it's not the case that I'll be wasting render time on buffers that I don't need on occasions when I do not wish to render them. And this is great. The custom buffer system lets you pull out all sorts of information from your surfacing and get that into custom buffers, which you can then, of course, use as you see fit or require in post-process or compositing. And so there we have it. That is the buffer system in Lightwave, all of the different ways of using it, the different places where we can see it, preview it, render it, save it, and so on and so forth. And with all of these options together, it gives us a really powerful, fully featured buffer system that is as good as we could really want for any kind of post-processing workflow.